1. Welcome all to today's ASRG-WORLD webinar. We have the 19th of August 2021 and we are streaming from Stuttgart in Germany. Thank you for being with us. My name is Sven Schran and I am coordinating with ASRG the European locations. The Automotive Security Research Group is now a bit more than 4 years old and we are a non-profit organization which provides a platform for the automotive security industry as well as related academics or organizations to share knowledge, build powerful networks and valuable collaborations. This community is for you and it is based on volunteer support. If you want to know more details about ASRG, please check out our website at www.asrg.io. Maybe you have an idea or a nice project and look for partners to realize it. You would like to start your own location, you have an idea about a service ASRG could provide, or you simply know a great organization which could partner with ASRG. We are open to hear each idea you have in mind and would like to discuss how ASRG can support it. Don't hesitate and get in touch with us. You quickly can send us an email with your thoughts to hello@asrg.io. So, this is now enough from my side and I don't want to keep you tortured anymore because I'm sure you are waiting very curiously for our main presentation. Like every time, in case you have questions during the presentation, please write it into the chat window. After the session, we will have some more minutes for questions and answers. And now it's my pleasure to welcome Dr. Jan Holle, Lead Product Manager, Dr. Siddharth Shukla, Product Manager, and Niclas Will, Research and Development Trainee from Escrypt. Today, they will present to us IDPS, a global legal and technological perspective. And now I would like to hand over to our guests today. The virtual stage is yours.
Thank you, Sven. Hello to everybody. Hello to the worldwide ASRG community. We are excited to be here and have the chance to talk about IDPS, intrusion detection and prevention solutions from a global and technology perspective. We are sure, as you're a security enthusiast in the automotive industry, you have heard a lot about IDS and maybe even IDPS. And today we would like to give you an overview on how we actually currently perceive what is happening here in the industry. For sure, it will be our own impression on what is happening in industry. So we are very much interested also in the later discussion and the Q&A, how you perceive the different activities in the industry to come to concrete and common conclusions. So what we prepared for you here is basically this agenda. We would start with a very nice welcome and introduction. We are in the middle of that already, but I will also introduce my co-presenters, and then we will have a look into the legislation and standards, because to be honest, IDPS is currently especially an important topic because legislators understood that it's so important. And so therefore there's multiple legislative activities ongoing, or there are legislations which are upcoming and will be active soon. And so it's important to understand what is the needs from that area. And so we will have Niclas talking about that. Afterwards, we will have a deep dive into the in-vehicle IDPS technology. So we will have a strong look on what is actually feasible today already in cars. It's not, let's say, only scientific research. We really see that you can do something as of today. And finally, we will have some slides on what we learned on during working with multiple OEMs in that area.
So it seems like Jan is has connection issues. You're muted, Jan. Still muted. But Sid, you can hear me, right?
Yes,
okay.
Jan, can you try to connect again?
So So can you hear me again?
Yes.
I'm very much sorry. Today's is my USB at home. It's a bit unstable today, and so the microphone was disconnected. I'm sorry for that. Okay, good. So as I already introduced, this is basically the agenda which we will follow today. And let's now switch into the first part in the introduction. So I would like to shortly introduce my co-presenters. And Niclas, can you please click? And another time. Here we go. So today I'm here with Sid. So Sid is originally from India, but he lived, I would say, everywhere in the world already. Lastly, he lived in Sweden, and he was there in our product development team in Sweden, where we develop both IDS as well as firewall technologies. And just recently, he joined our team here in Stuttgart, and so now he's getting to be a Swabian soon, I'm sure. And then we also have Niclas here today, who's working as a trainee in our product management team here in Stuttgart. And we will hear especially from him about the legal perspective and the standards about IDPS. Yeah. And myself, I'm Jan Holle. I'm also located in Stuttgart. I'm now in the automotive security industry, I think since 2009, actually, and joined Escrypt 2013. And I'm very happy to be responsible for our global IDPS team and global IDPS topics currently. So from that, let's directly jump into the topics. You can also read later on, if you stop the video here, about Escrypt, 16 years of automotive security expertise, market leader in that area. I think you're well aware of our company. Yeah, what is driving us if we talk about IDPS technology? So as mentioned already, we will for sure also hear about the legal activities, but as security people, for sure, we are not only following legal and just make a checkbox, but we really see that there's a necessity. And this necessity you will easily get if you look into the ever evolving global threat landscape. So we started, and I remember that well, in 2009 with the first automotive security attacks, which become more public, and then for sure in 2015 with the famous GPAC. And what was always there was the question, okay, could we have done more? And one of the things which was actually already mentioned also in that point in time by Miller and Walasek was, yes, we could do more by better building our cars, like secure with network segregation, for example, and many other security mechanisms, but also by being able to detect that somebody is actually attacking our cars. And that is something which is getting more and more important, especially as we see that more of our vehicles are automated. Yeah, and that means they possess a bigger risk if they are hacked. And on the other hand side, they are also more and more connected, which possesses or creates more risk that somebody is actually being able to connect to the vehicle and compromise the vehicle. So therefore, independently from the legal aspects, which we will see, we see really that IDS being able to detect and for prevention, being able to react on that is really also from a technology point of view, really important to build secure cars in the future. Please click, Niclas. If we at Escrypt talk about IDPS, we defined for us, or actually we reused from the NIST, a classification. And this classification helps us in our communication to make sure we always know what we're talking about. And we would like to shortly introduce you this this classification. Maybe you use different terms, but I think it will be easy then to map to actually your terms and understand what topics we're talking about. So first topic is network intrusion detection system. Yeah. So this is IDS systems, in-vehicle IDS systems, which have the goal to monitor the networks in the car and understand if there's anomalies in the network, which could be related to an attack. So the idea is you have typically a software component which you add to an ECU, and this is monitoring the surrounding networks. And that is, let's say, important because from that point, from this ECU, because it's maybe especially a secured ECU, you can make sure that wherever the attack happens in the car, you see the anomalies which are related to that. Just as a side effect, you see anomalies which are not only security related, and that may also help you to improve the quality of your car during validation phases. But that's just a side effect. For today, let's focus really here on security. So network IDS, look into the networks which surrounds your system where you have running your IDS. On the other hand side, we use the term host-based IDS for IDS systems which actually monitor the system itself where the IDS is running. So typically, this is a component running in an ECU, and typically it's especially ECUs which have a high or a big chance of being attacked. So like, for example, having complex operating systems or also, let's say, very powerful microprocessors and so. But you can also do this if there's good reasons for that on small ECUs like microcontroller-driven ECUs. And here the idea is really to detect security events which are related to this ECU and which could be tell us that this ECU is under attack. And in the best case, we have here detection on this actual ECU as the entry point to the car, so we know it in the moment it reaches the car. So you see already these two technologies, they amend each other. They are not exclusive, they amend each other because they are basically helping. The one is looking into everything, like the whole networks, and the other one is looking into an actual ECU. So very naturally, you will combine such solutions to get a full coverage in a car, and that is what we call a distributed IDS. Either we have multiple of the same type IDS systems, then it's simply distributed, or if we really combine both technologies like network IDS and host-based IDS, we talk about a hybrid distributed IDS system. If you are then able to also react on ongoing attacks, we like to call this an intrusion prevention system. We do this because the term is very much used also in the classical IT enterprise, and it's very much used meanwhile in the automotive, but we know that the P is actually not the best term. I would actually prefer to say it's an IDS reaction system, but as the term P is very well known in the industry, we just stick with it. IDPS means we are able to react on attacks. And then finally, to make this a complete solution, what you need is also the monitoring solution in backend infrastructure, a cloud, the organization for that. We call all that a vehicle security operations center. It's a security operations center as we know it from classical IT as well, where we have people, where we have infrastructure, we have organization processes to manage all the security events, but in this time, not from the IT enterprise components, but coming from the connected vehicle fleet. So this is basically in a glance how we basically use the terms in the area of IDPS, and I hope they will help you during the rest of the presentation, because now we basically step into the next section thinking about, okay, what is actually driving us beside the technical perspective? And actually one big driver is the legislation and standards which are happening across the globe, and Niclas will have us here and introduce us what is happening there.
Thanks for this introduction, Jan. So before starting, I want to give a little disclaimer. So we are no lawyers and can therefore not give any legal advice, but just provide information. And additionally, the legislation and standard landscape, in particular in China, is changing very rapidly. So we try our very best to keep track, but we can provide information only best to our knowledge. However, let's start with the regulations that are currently driving automotive cybersecurity a lot, and that probably most of you will have come across: the UN R155 and R156. The regulations were adopted last summer by the World Forum for Harmonization of Vehicle Regulations, the WP29, and should hence be made mandatory for vehicle type approval in participating countries, colored in green on the world map. The EU is making these requirements mandatory for the approval of new vehicle types by July 2022 and extended to existing vehicle types by July 2024. Other countries like Japan and Korea have similar timetables, meaning that from mid-2024 on, all OEMs which want to sell products in these markets need to fulfill the regulations. The UN regulations can be divided into four different disciplines, where the third one mentioned here, namely detecting and responding to security incidents across vehicle fleets, is the one where an IDPS helps in fulfilling the requirements. And in the following slides, we will have a deeper look which requirements these are exactly. So let's start with the 737 on the left side. It basically says three things. So first, the OEM shall implement measures to detect and prevent cyber attacks against vehicles, support monitoring capability, and provide data forensic capability. To detect concrete cyber attacks, primarily the in-vehicle IDS sensors are used. They allow an attack detection directly in the car, Furthermore, the information gathered by the sensors is then aggregated with further data in the VSOC and allows there even a better detection of attacks through the enriched data. This leads us to the prevention. By using the gathered data in the VSOC, appropriate responses like software updates or other reactions can be triggered. Furthermore, the firewall integrated in the vehicles allows an immediate prevention of the attacks. A further aspect which the VSOC provides is the monitoring and data forensics capability. So through the data gathered from different sources, it enables the OEM to detect new threats, vulnerabilities, and cyber attacks to the vehicle. Also, attempted or successful cyber attacks can be analyzed to learn more out of them for future attacks. Beside of these concrete measures in 737, the 7222, shown on the right side, requires the CSMS to also include processes to monitor, detect, and respond to cyber attacks, and to provide relevant data to support the analysis of the attacks. The 741 refers to these process requirements and requires the OEM to report the outcome of the monitoring activities also to the approval authority or the technical services. The VSOC is able to help in fulfilling all these processor requirements as it allows the extraction of relevant data for the different processes. So to conclude, we would say an IDPS is not explicitly required by the R155, but it is hard to fulfill the requirements without it. So beside of the mentioned paragraphs, the paragraph 734 requires all mitigations referred to in the annex should be implemented if they are relevant for the identified risks. However, if the mitigations are not relevant or sufficient, another appropriate mitigation must be implemented. The mitigations map to threats, which are shown on the slide. And first, from an holistic point of view, most of the mitigation measures should be also used as a data source for the distributed IDS. So let's give an example. For example, the R155 names the threat illegal, unauthorized changes to vehicle electronic ID, and as a mitigation to use access control techniques. However, the data or the events that are generated from these access control techniques should definitely also detected by an host-based IDS, and if relevant, then sent via the distributed IDS architecture. So let's come to the threats where the in-vehicle IDPS components support in their mitigation. So the first one shown here on the slide are malicious internal, for example, CAN messages. So as a mitigation, the R155 names here measures to detect malicious internal messages or activity should be considered. So this is then directly maps to CAN IDS or Ethernet IDS, so that an usage of either of these tools or both of them will lead to fulfilling or to tackling this threat here. Then there is the second threat is the diagnostic access used to facilitate an attack, e.g. manipulate vehicle parameters, and an mitigation of it named are security controls that shall be applied to external interfaces. So here an automotive firewall will help in mitigating these threats. The next threat I want to mention is the unauthorized deletion manipulation of system event logs. Here, the R155 names as mitigation access control techniques and designs. However, also by an host-based IDS, these activities can be discovered, and so it is totally useful to also monitor these activities and can use it, for example, later for data forensics. The same applies to the threat to introduce malicious software or malicious software activity. For both, or another threat are man-in-the-middle attacks or session hijacking. Here, a network-based IDS and firewall, as well as an host-based IDS can help. And then there are denial of service attacks. So they are split up in two threats in the R155. The first referring to the network explicitly. So it says here, internal network by flooding a CAN bus. And the second is sending a large number of garbage data to vehicle information system. And for both, for the CAN bus, a network IDS can, for example, help in detecting it, and a firewall can help to recover. And for the other one, with a large number of garbage to the vehicle information system, a host-based system, and host-based IDS installed on the according ECU can help to detect the attack. So, beside the UN regulations, other important legislations and standards are, of course, the one in China. In general, we can divide between legislations and standards. So the legislations are mandatory laws from Chinese authority, like the MIIT, so the Ministry of Industry and Information Technology of the People's Republic of China, long name here. However, they often refer to standards and thereby make the standards mandatory. The standards are published by different committees. So most relevant committees for automotive cybersecurity are the TC 115, which is the National Technical Committee of Automotive Standardization. So TC, of course, stands for Technical Committee. And the TC 260, which is the National Technical Committee of Information Security Standardization. There's a difference between the GBs, so the GB standards, and the GBT standards. The GB standards are mandatory, while the GBTs are only recommendations. When looking at the process for the standard publication, we see here that it consists of three phases. First, we have the planning phase, where we have the steps of pre-study, pre-plan, and plan issue. Then we have the development phase, where we have the drafting, the public comment, the examination, and finally, after the approval, we have the publication. Looking at the numbers of standards and legislations related to automotive security, we see that there are really many, but most of them are only planned yet, and many are under development. So, I mean, to read out the numbers here, we see that in total we have 11 legislations related to automotive security and 97 standards related to automotive security, which will probably be in place in 2024. So, as this is a really large number, we try in the following to focus on the most important ones regarding IDPS. A law defining similar requirements like the R155 and R156 will be the MIIT ICV type approval law, which will possibly take effect in 2022. The scope are intelligent connected vehicles, or short ICV, with high automation capabilities. And it seems to be currently not clear which vehicles are included in this definition. So I spoke to Chinese colleagues, and the opinions reached from all vehicles with connectivity to only autonomous driving cars from level 3 upward. So probably we will have to wait some time here until it is really until the law is really published. The current law is the current draft. Is currently on a high level, and more detailed requirements will follow soon. But it can be expected that several GBTs will be cited in this legislation, and they will be made mandatory, as explained before on the slide already. So coming to the IDPS requirements, in the current draft in Article 3, it says that OEMs shall take technical and other measures to protect vehicles and network facilities from attacks, intrusion, interference, and damage. So this is very similar to what is written in the R155. The requirements in Annex 2 3.3 to realize capabilities to prevent and respond to security risks and network vulnerabilities also matches very much the R155. And finally, in Annex 2 4.1, several of the threats discussed in detail before out of the UN R155 are described as well. So in general, it really seems like also the current draft is very similar to the R155 and R156. Further UN regulation-related standards in China include 2 standards which are equivalent to the R155 and R156, and which are both GBs. So this means they will be mandatory. So they are in a quite early stage, but they are estimated to be published in Q4 2022. And the difference here to the ICV law is that they will probably have passenger cars as their scope, meaning UNECE categories M and N. Another standard worth mentioning is the GBT, Road Vehicle Cybersecurity Engineering, which will be an equivalent to the ISO SAE 21434 and is estimated to be published in 2023. So as the drafts are currently in very early stage, it seems not to be worth going more into detail here, but just assuming that the requirements will be similar to the UN and ISO regulations. So a standard where I want to go more into detail, as it states even explicit security requirements for an IDPS solution, is the GBT standard named Technical Requirements for Cybersecurity of Vehicle Gateway. As the name says, the scope of the standard are gateways of all vehicles. It is currently a recommended standard, but could be made, of course, mandatory through the regulations. And it is estimated that it will be published end of this year. So beside of specifying concrete requirements, it also specifies how the according requirements must be tested. So there's basically a section of the requirements, and there's a section of how the requirements have to be tested. So this means optimally already in the development process, such a testing should be performed to be sure that then later the vehicle will be compliant. So the concrete IDPS related security requirements are the following. For CAN gateways, it requires a denial of service DOS attack detection. And as a testing requirement, it is specified that it must detect in a test setup a bus load of more than 80%. Then it requires to check the signal value in the CAN data frame according to the signal definition in the communication matrix, including DLC fields and signal value validity. So this means that before the car is put on the streets, or before the vehicle is put onto the streets, the signal values must be defined, and it must be checked that that they are really in the range that is specified here. So to test that, it is specified that frames with invalid signal values must be sent and frames with invalid DLC fields. Also, another requirement are large differences between the transmission frequency of data frame or the signal value content. So this means that if an CAN message that is expected to come with an cycle time of X, and it is over the cycle time too much, then this has to be detected. Furthermore, also, if the signal value jumps too much, this also has to be detected. The last requirement stated here regarding to IDPS is to check whether the CAN channel initiated by the UDS session is normal. This means that normal channels usually include the channel connecting OBD2 port and the channel connecting onboard information to active system. For Ethernet gateways, a firewall or access control list should be used following default denial principles. It is stated very explicitly what must be at least done by this firewall or ACL. So the source IP address must be included, the destination IP address must be included, the protocol type, the protocol source port, the protocol destination port, the physical port, the source MAC address, the destination MAC address, and others. So it's really clearly stated here. The same applies for the denial of service attack detection. So the GBT requires that at least 3 types of DOS attacks are detected, namely ICMP, TCP, and UDP flooding attacks. And last but not least, the protocol state detection, where it is required that TCP handshake status, packet length, packet sequence, and TCP session closing status is monitored here and logged if not according. Furthermore, there are also more GBTs. GBTs over GBTs here. So the first GBT is the GBT technical requirements for cybersecurity of remote service and management system for electric vehicles. So as the name says, it applies for electric vehicles of category N, and it is estimated to be published in end of 2021. For the onboard interface, it also has quite explicit requirements, namely to determine to allow or refuse the access of data packages and to carry out intrusion detection, where here also an detection rate is defined. The second GBT is about charging systems, and here for the onboard unit network interface, also on firewall or ACL is required. And the third one is general technical requirements for vehicle cybersecurity. It applies for ICV, is estimated to be published in 2021. And here, it requires border access control mechanisms and perceive abnormal messages. And also interesting here is that it requires not only on a network level an IDS, but it also required what we called before a host-based IDS. So here defined as the in-vehicle software system should have the ability to perceive security events that it is attacked and perform responses. After this overview on the legislation and standards regarding IDPS, I want to hand over to Sid. Sid will provide more technical details on in-vehicle IDPS technologies and give an insight into future zonal EE architectures from in-vehicle IDPS perspective.
Thank you, Niclas, for this wonderful presentation and insight on, let's say, the legislations which are driving the IDPS journey itself. So yeah, as Niclas mentioned, I will be giving a little bit more detailed insight on what are the current in-vehicle IDPS technologies that we see which could fulfill the current or maybe also the future technical needs as well as the legal side of it. So it's the slide is again an insight to what Jan already presented, and here basically what I want to show is, I mean, the building blocks of IDS could be the in-vehicle component as well as the backend, and here we will be looking into what are the multiple different in-vehicle components that that help you to establish the overall in-vehicle anomaly detection. So on the sensor side, you can see there are multiple classifications like be it network IDS or host-based IDS, and these components or detection components are termed as sensors or IDS sensors. And in the picture here, some of the IDS sensors include intrusion detection for CAN and Ethernet, which comes under network IDS. Then comes host-based IDS, which is basically really targeting specific hosts or specific systems. Then comes Ethernet firewall itself. So, I mean, though Ethernet firewall is dropping messages, but it can also contribute to security events. When all these sensors are responsible for generating the events, but what to do with those events, or how to really collect events together and then try to aggregate and make sense of it. Those requirements are fulfilled by the so-called Ids Distribution Framework, and that includes IDS Manager or IDSM, which has been already standardized in AUTOSAR, and its responsibility is to collect and aggregate events. And then comes IDS-R, which is Intrusion Detection System Reporter, and its job is to basically get the final set of events and then send it to the backend or to the vSOC for further analysis. Now, in the next slides, we will look into more details on each of the sensors or the distribution framework components, which will do the detection. Coming to the first one, which is network intrusion detection for CAN and CAN-FD. So basically, the responsibility of this IDS sensor is to monitor CAN traffic and detect potential attacks be it messages which are injected by an attacker, or maybe the attacker is trying to do something else within it. Typically, it's classified into either rule-based or machine learning based, could be supervised or unsupervised. But at least based on our experience from the market, at least currently we see rule-based approach as a more preferable solution. So the further details I give are really focusing on rule-based approach. So the idea with rule-based approach is that you specify really the known good behavior of the vehicle or the e-architecture and anomalies in terms of rules. So we see that the OEMs have already invested a lot of time and money to define the basically in specification of in-vehicle communication. So the best thing would be to take advantage of that invest and use them to generate rules, and then basically generate effective and efficient in-vehicle implementation. So the reason to say effective and efficient in-vehicle implementation is that with CAN IDS, we need to target ECUs of today as well as future, and as we know that in today's ECU, some ECUs could be really small, where you have limited resources, and therefore it makes sense to also make sure that the footprint fits well into the current ECUs. Some of the sample detection features of CAN IDS could be like observing the frequency of message to detect if there is any kind of message injection. So which means that if the message is supposed to come 10 times in let's say 1 second, if it is coming too fast or too slow or not coming at all, then it could represent an anomaly, and detecting that could be really useful. Then another could be to compare all messages on the buses with a whitelist to detect if it's an unspecified message, which is not supposed to arrive at all, but we can see that on the bus. Then, on CAN side, we know that the UDS interface is one of the very high potential attack surface, and so detecting malicious diagnostic requests while driving on certain ECUs, or for example, detect attempts to shut down ECU when it's running. So these kind of detections are really, let's say, important and useful. Coming to the configuration itself, so as I mentioned, we are focusing more on rule-based approach. So the idea there is that using the vehicle CAN database information like UDBC files or ARXML files, we can generate some kind of initial configuration, and with help of recorded CAN traffic, or basically could be with or without anomalies, and some other information from the vehicle. You can fine tune your configuration to reduce the false positive or improve the detection rate, and that's how you basically generate the configuration. And yeah, and it could be you can have generate very simple configuration, but also very complex ones. And typically, I mean, on CAN IDS side, the challenges that we see more or less is, yeah, as I said, the current ECUs are small, so mostly with respect to resources, and also how many rules you want to configure, and also, I mean, other things definitely. The configuration could be, you may need some real experience in that area to do the configuration. Now we will look into the Ethernet part itself. So yeah, before I really describe Ethernet IDS, I also wanted to do a clear classification, make a clear classification between what firewall or IDS is for me with respect to Ethernet, and what could be the clear boundary line between them. Because yeah, Ethernet with Ethernet, we have one thing, which is the benefit as well as the problem, and that's speed. So if you have high speed, but processing those packets at that high speed is not that easy. So coming to the firewall itself. So for me, I mean, it's the left picture you see here. So the job of firewall is to block illegitimate communication to one or multiple ECUs, or maybe to the entire network, depending on the policy. And the difference compared to IDS here is that the firewall is sitting in between the normal message flow, which means it looks into every message and decides if it is right or wrong. And therefore, it has hard latency deadlines, because it is where you have certain time limit based on the requirements uh, in which you need to process the packet. Also, the rules should be very clear and it cannot be ambiguous. So it needs a clear identification if it's a right message or wrong message. If it's wrong, you drop it. If it is right, you allow it. Coming to IDS itself, on the right side, we see that it is a module which is running in parallel to the normal message flow. Therefore, it does not have any hard timing requirements or latency requirements. Also, the focus here is more on monitoring the behavior or pattern to detect anomaly and then create intrusion report. Now we will separately see both of these components. The next slides. Yeah, coming to firewall. So yeah, as I mentioned, the job of firewall is to really inspect packet and decide is right or wrong. So it inspects, be it incoming or outgoing or both, Ethernet messages in an ECU, and then block or allow them within bounded latency. So some of the use cases or responsibilities of the firewall could be to maintain and enforce basically a separation of network segments using VLANs to support different domains in vehicle. Then establishing and preserving communication domains on all Ethernet and IP layers or in the OSI model. So which means that more or less there could be requirements on the simple stateless packet filter, which means where you clearly define what information in the header you would like to look for. Also, Niclas mentioned some of the information in his previous slides. That could be MAC address or IP address, source port, destination port, VLAN ID, ether type, etc. And you clearly define what to look for in the message, and you look at it, and if it's correct, it's fine. It enters the system. If it's not correct, you drop it. The second type of firewall is stateful packet inspection, and stateful packet inspection has more focus on, let's say, dynamic states. So an example here could be TCP communication. So in TCP, the client and server first needs to establish a connection, and the state of connection can change dynamically during runtime. So for every possible client and server, you need to maintain a state machine and do connection tracking. And if something is not following the right standard, or maybe could be RFC 793, then it needs to be dropped. TCP is just an example, but there are more stateful protocols which are quite popular in automotive world. The third one is deep packet inspection, and this is, let's say, a very unclear term from my experience. So for me, deep packet inspection could be either looking into some payloads of the packet or inspecting some application layer protocols like diagnostic over IP or some IP, etc. Another aspect of firewall could be like really association of vehicle context to offer state-aware policing, which means that I mean there could be certain messages which are supposed to arrive only when you are driving or only when you are in certain diagnostic mode. So it makes sense to really be able to map the vehicle state or context to a firewall policy. And then we also see needs for enforcing the communication policy based on both whitelist and blacklist approach. So with whitelist, you clearly define what message should enter your system or not. Basically, with blacklist, you clearly define what should not enter your system. So, with blacklist, you can prevent known attacks. And as you see on the right side, the picture is quite complex. On Ethernet side compared to CAN, because there are too many different protocols at different layers, and more or less, you need to support all of them. So you really need some kind of modular approach where you can that can allow you to use the current systems and have you can have a small footprint, but still be able to support like most of the protocols being used by customers. Now we will look into the IDS side of Ethernet. So when coming to IDS side of Ethernet, I mean the job of IDS here is to monitor Ethernet traffic and detect potential attacks by really focusing on behavior or pattern analysis. So the idea here is that you define all legal behavior or the allowed behavior of the vehicle, and with that you do unauthorized message detection or you validate the data. Then you do access control. So with access control, you can really detect what are the malformed frames, and if there is something not right, you can find that. And these all are basically based on whitelisting. So the better or more clear whitelist you have, you can at least have a very clear identification of what is right and what is not right, or maybe a little bit more ambiguous side, but at least you know more. And the whitelisting can be based on multiple fields, be it the packet header specification, be it the stateful behavior of protocols like TCP or some IP or other things. Could be timeouts, because that's also a thing with service-oriented communication. So you want the connection to be active for certain seconds if there is no certain time if there is no communication ongoing. So you can include timeouts, you can include payload, and also very higher layer information from the protocols like dynamic over IP or some IP or other application layer protocols. Again, you can do state and context-aware whitelisting, and here could be that the message to flash ECU is not allowed when the vehicle is running. Also, you can link more time-based statistical analysis here with the help of doing frequency detection or checking the rate, or where a very high or low message rate can define an abnormal behavior. You can also check the rate of change of signal, so how fast the signal is changing, and if maybe not that much valid for Ethernet, but a simple example could be that if the speed of vehicle is defined in a signal and it changes from 0 to 200 in just a second, then maybe it's something really wrong and it should be looked at. Other checks could be like really looking into the size of message or sequence of message. So, I mean, looking into the detection algorithms or detection method, it looks quite similar to CAN, but it is really different from perspective that here you have really high message load. So you have really a lot of data coming in, and you need certain different ways to figure out how you can really deal with all the data. You can still do detection and also fit in the current architectures. So the overall idea, as I shared on the left side with Ethernet IDS, is that with help of, let's say, the information available from the very low layer from OSI to the application layer, you link them all together and you generate a very good whitelist or detailed whitelist, and then associate it with the state of vehicle, the time domain, and also the sequence domain. And these are the three different areas that can allow you to develop very sophisticated IDS rules, and that can help you detect different anomalies. Now, moving from network IDS, we jump to host-based IDS, and host-based IDS is a little bit different compared to network IDS. So, I mean, it is not one standard product that you can use to say, okay, this is an off-the-shelf product, and you use to have it as a host-based IDS. It is really a customized solution which allows you the possibility to adapt to any scope of monitoring depending on the security risk. So the steps here are, you really analyze the security of your system. Once you've done that, you look into the measures to harden your system. And then you configure the standard monitoring of the available features, and also maybe some other sensors. And then you really identify, define, and implement system-specific monitoring points. So it could not be standard, but you really define or develop, if needed, some monitoring or capabilities in your which are specific to that system. And then at the end, you collect, aggregate, and basically report events from different sources. So that's the process side on the right side you see. So what the key message here is that it's clearly a risk-based security monitoring of automotive ECUs. It's not standard, and but the benefit of it is that it can really target anything. It's not really specific to a single need, like you are monitoring a bus or something, but you can really adapt it to your system. The main targets of host-based IDS are typically systems with rich operating system and external interfaces, and typically like with big processors maybe, but it is also applicable for small ECUs depending on the use cases. Some examples of what host-based IDS could focus on, what are the areas, could be monitoring the network access, or monitoring the Bluetooth interface or wireless interface, malware detection, or monitoring the file system or system calls in an OS, or multiple other things. So it has a variety of use cases. So which means that you really, for a host-based IDS, you may need a selection of tools from a big toolbox, more or less, and then exploitation of also the existing monitoring and logging capability available in the system, and also be the security features of the system. And it should also allow you to integrate the third-party IDPS components, because here we are, host-based IDS in certain use cases can only make sense when it is also utilizing some events generated by IDS, different IDS sensors, and then you combine it all together and try to make sense out of it. So that's how host-based IDS works. And as I said, the clear message here is it's not straightforward, it's not off the shelf, but it really is depending on different ECUs and different systems. Then the last IDS components that, or the IDS component we will be focusing on is the Ids Distribution Framework itself. So here there are two major or two parts. One is IDSM, or the IDS manager, and then the second one is IDSR, which is the IDS reporter. So it is the standard AutoSAR compliant solution, which is designed to be flexibly extended to cover any customer aggregation, persistence, or reporting strategy. Coming to that, for what I said, IDSM is definitely standardized, but IDSR is not yet standardized in AutoSAR. So the two parts, IDSM, the IDS manager component is could be for big platforms or big ECUs like with vehicle computers, but another variant of IDSM or IDS manager could also run on small ECUs, because on small ECUs as well you have need to collect or aggregate events. The IDSR, or the IDS reporter, is a component which is basically reporting the events which are collected. So if you see the picture on the right side, we can see that there could be more than one IDSM in your vehicle. So the IDSM basically could aggregate security events on the ECU level itself, or the domain level, which is in the domain ECUs, or at the centrally at the vehicle level. It communicates security events to IDS reporter or other managers. So, in this example, we see that the classic AutoSAR ECU has an IDSM, and the adaptive AutoSAR ECU has IDSM, and then basically the events here are aggregated to the adaptive AutoSAR ECU in the hierarchy above, and then the events are aggregated together and sent to the VSOC. The IDS reporter is basically the communicating the security events to the VSOC. Now we will look into the last slide from my side, and which is really focusing on zonal E architecture, and it's giving a perspective on how these IDS components could really look like in a future zonal E architecture, and it could really fulfill all the IDS needs, at least we see now. So as we know, zonal E architecture is really about dividing the vehicle into different areas where which are taking care of multiple functions. So here we see that centrally we see multiple use cases from the firewall side. So if you look into Ethernet firewall, it could run on vehicle server centrally, could run an Ethernet switch, but could also serve applications for small ECUs, like for electric vehicle charging use cases and everything. Coming to network IDS, be it for Ethernet or Ethernet or CAN. So the network IDS could have multiple use cases on the vehicle computer, be it domain controllers, which have a lot of many connections to CAN and network Ethernet bus, but also to the end ECUs. The IDS manager component, like the slide before, it has multiple use cases on the vehicle server, where the main or the big IDS manager component would be running and could be aggregating even from the entire vehicle, but also in the sub levels at the domain controller or NDCUs. And then the final IDS reporter component, typically you need only one, where you have connection to the backend, and in this use case it could be centrally on the vehicle server or the central vehicle computer. So here we see the approach here could also cover not only the architectures of today, but also the upcoming architectures which we are aiming in to have in the automotive industry. So after this insight I gave on from a technical perspective, but also what Niclas explained on the legislation side, I would like Jan to now present more on how our OEMs are trying to deal with this, and what are the IDPS strategies from the OEM side.
Thank you, Sid. And first of all, I hope that some of you are at least still with us, because we already spent 55 minutes talking about IDPS and what is driving this market, but also about the technologies. So therefore, I will also try to be brief, actually, in our stories, I would say, to tell from OEM adventures here. So first of all, how we see it is IDPS. There is a silver bullet, meaning that you have really an accepted way now to do it in the industry, we would say. But there is no easy path to that. What do we mean by that? We mean that most OEMs, and here we mean especially the OEMs in Europe, but also in Asia Pacific. I have to say that North America is still a bit different from what we perceive on the market, but also there, let's say, there's a lot of discussion, and I would expect that they are striving towards the same direction. So they all target a comprehensive IDPS approach. What do we mean by that? We mean it's an approach where you have in-vehicle intrusion detection systems and a VSOC. This is in general what we see as the widely accepted approach, while actually if we go one step deeper, we see that there is quite some differences. So that means, for example, that the targeted scope of in-vehicle detection is quite different. So there's really OEMs looking more into network IDS, there's more looking into host-based IDS, the most of them looking into both. Also, this is meaningful if we see or reference back to the legislations which have been introduced by Niclas, especially if we look to China, where it's very hard to argue go for one or the other, but it's the right mixture for your vehicle. But right now there is still a very different scope. Then there's also very different scope if it comes to the VSOC, the Vehicle Secured Operations Center, because there's really companies who believe, okay, we could do it by simply collecting the events, and then one or the other day somebody's looking into that. And there's others which really take the legislation very serious, which says you need to timely react, and which really think about having a fully staffed 24/7 operational global VSOC organization and team. And then for sure, there's very different implementation approaches. There's for sure always the make or buy decision. And also there's a lot of customers looking really into managed services here, because it's really hard, I would say, especially for small and mid-size OEMs to have this just as a product which you buy. But at the end of the day, you really want to have a service so that you don't need to bother yourself too much and have too much expertise in-house actually. So the challenges which we typically see if our customers introduce IDPS technology and we help them to make these challenges as easy as possible is how to do a lifetime service. So the IDPS components really needs to be up to date for the whole vehicle lifetime. And also the VSOC needs to be operational until vehicle end of life. So this is for most of the OEMs the first time that they have this challenge. And so this is quite a challenge to think in that way. Also, typically we see that internal organization and supply chain is a big topic, because you have basically in-vehicle components and you have IT components and you have services, and somebody needs to buy all that together or get all this together to make a complete solution out of that. And sometimes it's simply the matter of who's responsible for these topics in the companies. It's important to take an end-to-end view, and an end-to-end view here means really from the technology side on the one hand side, but also including, let's say, the integration aspect, the legal aspect, the procedural aspects, and the organizational aspects. Because if you have a very nice IDS, but you have no team to make sense out of it, it's not very much useful. And then for sure, as always in the automotive industry, budget is a real topic here. So to be honest, the introduction of an IDPS will cost. It will increase the cost in the development actually, where we see typical license cost, engineering service, and so on, but especially also in operations. So the question is also how to make out of that a business model, I would say. And then another question, especially if we look into the UN regulations for 2024, is for sure how to support legacy platform where we don't have so much resources. And as mentioned earlier in the rule-based IDS for CAN, here we really need to tweak then the solution to what is available actually, and then make another risk-based approach and say, okay, this is what we can afford. And getting the right technical expertise on board, that's also what we see typically as a challenge. So this is basically just to give you an idea what's happening in industry with respect to challenges. So let's have a next look to what is typical questions actually here. So typical questions which we see at our customers, and it's only a selection for sure, is like this for example. So the question, what data shall we gather? And what does the data tell us? Many of our customers already have a lot of data which is sent from the vehicle and which could be used for sure also for security purposes. But the question is it good enough? So to be honest, it depends, right? So you need to really deeply analyze what kind of information is there. And if you are lucky, some of the information is indeed related or can be related to security events, and you can have a very first detection with that. My personal opinion is that you still need specific components in the car to detect actual security related events, because this is a special look on communication, on system behavior, and so on. But certainly it's a starting point. And definitely it's no waste to look into that, because it can be used to correlate. And especially if you have an IDS system and you get some events and you have some more data to correlate, it's very much helpful to manage, for example, false positives or to understand the severity of an actually an IDS event. Another big question which always comes is how to reduce the false positives, or what's about false positives in general. And I have to say, first of all, if you have a good system where you can remedy false positives over time, where there is a mechanism for that, it's not a disaster to have some in the beginning. It at least tells you the system is working and you will learn something about the behavior of the system. But the important thing here is really to be able to remedy over time. If you have them for the rest of your vehicle lifetime, you will be dead by security events. So therefore, a good IDPS solution from our point of view should have a good tooling which helps you to get rid of these false positives, and this should happen as early as possible in the detection. So we have seen this architecture really should happen in the best way in the IDS sensor, latest then in the IDS manager, because if not, if it's already sent out to the VSOC, it will be quite costly already. Sure, you can do another filtering in the VSOC, and that's especially for a certain amount of time good, but get it as much as early as possible in the detection chains helping you. Two last questions which we often face is, or which we often see, is how to maintain an IDPS over lifetime. And my personal recommendation is, and for sure it's because we follow this approach as well, enable your team to take care. So you should have really a transparent solution to get your team trained and involved and being able to maintain this technology over time by yourself. You can absolutely buy services around that, no question, and it's a good thing to manage costs, but you should understand what's happening. No voodoo. That was one of an OEM engineer told me some years ago. I don't want to have voodoo in my car. I want to understand what's actually happening. And finally, a very important question is also how to handle vehicle variants. And here, this is really a capability of your IDS system that is able to generate configurations and work with the system in a way that you're robust against some vehicle variants and have coverage for some vehicle variants, because only in that way you will manage the IDPS components over lifetime with multiple vehicle variants. Yeah, this is basically some questions, and if you have not yet started with IDPS, I'm sure you will meet some of them. But the interesting thing and the important thing is here the point number 3 on this slide: collaborate and share. And so I'm very happy that we are here today at the ASRG, because that's exactly the forum which is needed for that. We all share the same challenges here right now, the whole industry, and so we should really share our experiences here and help each other to get across that, to at the end of the day make vehicles more secure. And for example, especially if we are able to detect what's ongoing in our vehicles, then we also want to share this threat information, because we want to learn from each other, so that one is ready after the other have seen that attack already. Just to reference back to the old hacks, which are very famous, this ECUs which had been part of these hacks was in way more vehicles than just the ones which have been at that point in time published. The attack was not working the very same way, but very similar way. So therefore, it's really important that we learn from each other to get this under control. There's another recommendation here: don't wait. IDPS is coming. I think we have seen the timeline from the legislation, and get ready for that. It's really something which is good. And here's another trick: begin in good time. Interestingly, IDS is also a nice validation tool. So if you have a good IDS, it will tell you during vehicle validation phase what's going wrong in your actual car. And that will help you to improve the quality, because you can say to your supplier, hey, I see this and this messages, for example, on the bus. I have not specified them. Why do you send them? You send signals out of range. Why do you send them? So you can very easily and fully automated find such kind of cases. So therefore, my personal recommendation is, especially with respect to network IDS, if you start early in the vehicle development, you learn during vehicle validation, and you get configuration, the first one, more or less, free of charge. So therefore, that's something where I really recommend to start early. Even the car is not yet fully there, you can start with software in a loop, hardware in a loop, and then with the car, and so you will learn all the time. So I don't go to the 5 first steps, which are defined here in detail, but we just collected them here. And in a very much nutshell, we would like to repeat here. You need to define a good strategy for security monitoring, which you want to use, and you need to conduct a risk-based security analysis of your EE architecture to find the right solutions and to combine it the best way. Then basically, you also need to think about realizing the necessary infrastructure. We already mentioned the VSOC, and here an important tip is also don't forget your IT department. We have seen multiple customers which started very much on the in-vehicle side, and we had a quite good solution then. But then the question came up, okay, who should work with that? And then the discussions with the IT department started. And as they had been not ready, they had no budget for that, and so on. Things got delayed and so on. So really get those people in from the very first moment. And finally, again, train your organization and adapt regularly. That's really important. Yeah, that's very briefly what we see, what's happening with challenges at our customers. And I would like to conclude, and I would like to invite Sid and Niclas again back to the stage. Maybe you can turn on your cameras already for a small summary here. Niclas, could you show them, please, the summary?
Yes, sure.
Yes, wonderful. So very briefly here, what we have told you today is, so there's many upcoming regulations and standards. We have only seen today UNECE and the Chinese standards, but there's way more globally, yeah. But they all go the very same direction. They say you need to be able to detect and react. And some of them are really quite specific already on the technologies here. So therefore, also you need to look very much, to get this done. And many of the OEMs started to also really take these requirements now over into their security specifications. So therefore, also the supply chain need to be ready to cope with that, I would say. And then the second thing which we really want to say, your IDPS approach is specific to your EE architecture. So you need to have experts, you need to have a flexible framework with different IDS systems to make the IDPS as best suited to your actual EE architecture as possible. Because only then you will have an effective and an efficient solution. You need to have open interfaces, transparent technology, and interoperability is really key. And so we are really happy about the new IDSM standard in AUTOSAR. Actually, we heavily contributed to that because we really feel that multiple IDS components in a car needs to be able to work together. And for sure, the very next step will be also to see how much of this can be standardized also on the way to the VSOC. And that is necessary because you need to consider this in an end-to-end manner. Yeah, you need to consider it from the IDS sensor to the actual VSOC. The third thing which I tried to tell you is IDPS. Yes, there is meanwhile a silver bullet, meaning that the industry has a common sense of understanding. This is what we are seeing. Yeah, but there is no easy path. It's a manageable path, but it's no easy path. So therefore, we really invite you to start early, and happy to see a lot of collaboration, maybe also here in the ASRG forum. Maybe that's a good place to exchange experiences about that. And then finally, yeah, we all share the same challenges. I said this already. Yeah, so therefore we should also collaborate here, because only then we will have, as mentioned above, an costly, not costly, but a very efficient and solution which is avoiding costly quick fixes. If we share with each other, I think we can reduce for all of us the efforts, the cost, and we can learn from each other, and then we can have secure connected fleets in the future. So after that, and a lot of time, this is basically what we would like to tell you about IDPS at a global and legal technology perspective. And we hope you have enjoyed our presentation, and we are more than happy to receive some questions. And I think, Sven, you had a look to the chat window at YouTube. Happy to receive questions.
Okay, so at first, thank you very much to share your knowledge and also your experience with us, and to cover different aspects here. I would like to start with some questions we received. So let's start with looking again to the legislation part. One question we received is, if the IDPS fails, are the OEMs being held liable for resulting issues?
Yes, I think I would take up the question. So I think first, it depends on the country where you're in. So I mean, all the countries have different legislations. So this depends, of course, in the country. But in general, I would say there are maybe two cases. So the first case, if it fails without an attack happening. So if it just fails and the OEM did something wrong. So then I think the case is clear. Okay, probably the OEM will held reliable. I think the second case is if it fails when an attack happens, so it just lets the attack through. And in IT security, you always say, okay, there is no 100% security. And So for this reason, probably in this case, the OEM will not be made reliable if he took the appropriate measures. So I think it's a quite tricky question, to be honest. But so in general, I would say sometimes even the opposite is the case, as if you take measures and implement something like an IDPS, you will be made less reliable as you at least took measures and put security mechanisms in your vehicle.
Okay, thanks for answering that. The next question is, if a VSOC somehow required to fulfill the laws or the legislation part, or is there at least a recommendation to have a VSOC?
So, I mean, I think I showed before, I don't know, it was on slide 9 or something like this, what is exactly written in the regulations. So our conclusion was here that it's not required, basically, but however, it helps in fulfilling the requirements. So, I mean, these are legal terms, so they are often easy to fulfill, they are also, so it's often also possible to fulfill them with other techniques. However, we would say we recommend to use an VSOC here to offer the monitoring capabilities, for example, that are required by the legislations and regulations.
Okay, thanks for answering that. Now coming to the aspects which are more technical based, there's one question about how the information will be provided to the VSOC. There's a protocol named here, it's MTTQ. Is this a very famous protocol to use?
MQTT, I would guess this.
Yeah.
Yeah.
Okay.
Okay. Sid, shall I do?
Yeah, please go ahead.
Yeah, good. Yeah, so first of all, yeah, so this AUTOSTAR standard, which we mentioned, is just mentioning or standardizing the security event format, so how the security events go into the IDSM, and then the outside format, which is saying the qualified security events, how they go from IDSM to IDSR. Then the question is indeed, how do the events come from the IDSR to the VSOC? And this is not, let's say, standardized, and there's very different ways to do it. MQTT actually is a very famous solution for that, and we are working with that as well. But there's also other implementations which you could use, like more REST-based approaches, for example. Yeah, and more protocols. Yeah. So, but at the end of the day, this is, I would say, internet transport protocols which are well established, and so the question is always, what's the most efficient implementation? Yeah. So, and the question is, do you want to have, let's say, the VSOC from the one vendor, or you have an own solution, or do you want to have that and the IDSR from another vendor, or you want to have all from one hand? Then you don't need to bother about that. So therefore, let's say, there's famous protocols like MQTT, for example, but at the end of the day, there's no standard about that. So you also have quite freedom. So also, for example, our IDSR approach here is to support multiple protocols, because if the VSOC is not our VSOC, then for sure we need to support different protocols to make this work, and vice versa. The VSOC also, our VSOC also is able to work with different input protocols to make this work.
Okay, so thanks. The next question, can you give an outlook when you roughly expect the new architectures you present are really be on the road?
Should I take it, Jan, or you want?
Yeah, please.
Okay. I mean, the new architectures, I mean, here we see a huge difference, let's say, among the OEMs itself. So, I mean, there is a really huge difference in what architecture they are choosing right now. So some have actually skipped generations, and they really are targeting to go with the zonal E architecture in next 2 years, more or less. But yeah, so we see a mix. So we see a mix where you still use central gateways, and you try to have a domain-based E architecture with CAN and Ethernet combined. But also we see a lot of customers directly aiming for zonal E architecture, where you have more central computing, and that's also a very popular approach we see. And especially, I mean, we see that trend in Asia, or also at some places in the US. So, yeah, so I mean, maybe if everything goes well, you can see on-road vehicles in 2 years, if I mean that's what they talk about, but also it could take some more time. But at least what we see is that the direction they are moving into is clear.
Okay, thanks for answering that. Next question is regarding the different vehicle types, which are also defined by the UN, for example. Are you planning for the different vehicle types, different IDSs, or can more or less the same architecture used for the different types of vehicles?
Mm-hmm. Yeah, so basically the basic building blocks, I would say, are very much the same. I mean, in all these vehicles, we see networks, we see ECUs, so there's a lot of reuse, but there is certainly different aspects where you want to have a special look on. So, for example, one very specific aspect is actually in trucks. In trucks, you typically see not only CAN, but on top of CAN, you see the J1939 protocol, which is a specific protocol to standardize some communication between truck components because there's a lot of combined business where different vendors combine to build the actual truck. So this is very specific to this market, and an IDS which can work with such a kind of specifics is way more effective because that gives new attacks which you want to detect, but it also gives you an easy way, for example, to do good configurations because you can learn from this standards a lot. So it's both, it's danger and it's help. So therefore, I would say the basic building blocks are the same, but it's very good if you can also support the specific cases, like for example in the trucks, or for example, I think I said you mentioned that also if you have an electric vehicle, then you have the charging application, which doesn't make sense in a combustion engine situation. Yeah, but also you want to cover that to have the full coverage at the end of the day.
Okay, thanks. The next question is a little bit more deep technical. From your experience or your ideas, how you can distinguish in an IDPS if you look for a denial of service of a network, for example, from a fault of the device itself. So let's say a microcontroller trap or the communication controller is broken, and that's the reason why there's no communication anymore.
Mm-hmm. Complicated question for sure, because it really depends on the actual case. So I mean, for sure there is, let's say, multiple denial of service variants, I would say. Yeah, and it's certainly a difference if the connectivity is broken, for example, so like a line is broken or you have another defect or so, then you see a lot of error frames, for example, or if the network is, for example, flooded, which we typically see as an attack in CAN networks, and that is different from the detection behavior, and so therefore also from the information you can gather at the end of the day. But it's true, actually, we also see cases where we have just an anomaly and then only additional information around, like maybe from other ECUs, which see this from a different perspective, helps to understand what actually happened. Yeah? So it's not always that a single event can tell you the truth. And so therefore, it's very important that we are able to really aggregate in the vehicle and later on even analyze in the Vehicle Security Operations Center to understand such cases.
Okay, thanks. If we look for artificial intelligence, do you see use cases maybe in the future where this can also help somehow in the IDPS systems?
Mm-hmm. Yeah, absolutely. So let's say, as we stated, we currently follow with most of our products a rule-based approach, and this seems to be also widely accepted in the industry. Also, a lot of the companies which did make decision, at least for first generation, and some of them now changing again to buy a decision, but most of them also followed this rule-based approach. The reason for that is simple. Our current networks are very well specified, so it's very simple to build good and effective rules. And on the other hand side, the implementation is very small, very efficient, so it can really fit into their microcontrollers. So both things will change over life. So we will see more dynamic behavior, which can be less described in such static roles. And we will also see generations where we have more performance in computing, and so we could simply adapt the AI-based technologies here. What my personal opinion is that we will see multiple generations of IDPS systems, so over time they will develop. And what I can see is that we will see a hybrid system where we will have a lot of the stuff done by rules, rules, and by that have a very efficient system. And then there's areas where it's hard to define rules because it's really very dynamic and specific to the actual car. And here we have then a combination where we also have a small AI system running inside of a rule specified system. And that's basically what I see as the next evolution step, I would say. But certainly for the first generations, you're good to go with a rule-based IDS. And by first generation, I mean like next vehicle generation, next or so. So that is what we currently see. But yeah, I mean, technology is evolving. So let's see what is next. And we certainly look into that. We have people also doing research in that. And whenever we see that that is the better solution, we will add it to our solution to make a complete picture.
Okay, thanks for this outlook. Another interesting question. If there is an attack happen which bypasses the IDPS system, which companies, from your opinion, can help personal car drivers to recover? Or also if we look for motor fleet owners, who can help them to recover the fleet in that case?
I'm not 100% sure if I got the question, but if I got it right, then the question is about, okay, when really something happened, who could help to remedy the problem? Let's say if you're not able to do it by yourself or so. Maybe that was the question. I'm not sure if I fully got it. Yeah, and actually, that is an interesting point where we also see that there's currently a lot of demand is actually in forensic specialists and responsive specialists, incident response as a service. So this is a well-known service in enterprise IT. So also